Hello everyone and welcome to my presentation. Today I'd like to bring to you our presentation of the vision paper entitled Continuous Experimentation on Artificial Intelligence Software, a Research Agenda. So the work is done by Nguyen-Duc from University of Southeastern Norway and Pekka Abrahamsson from University of Jyväskylä in Finland. Nowadays, we can find artificial intelligence or machine learning code everywhere. For instance, it's easy to find a Git repository with ML codes have a large number of forks. Artificial intelligence as a field has existed for more than 6 decades, but most of its lifetime as a science, not as an industry. And today, AI code has moved from research papers, demo tools, to be parts of large software systems in own application domains. And software-intensive organizations are hiring artificial intelligence scientists and engineers to work with different aspects of their AI projects, from data management, model building, testing, operations, and integrations. And it's more than ever, there's a needs of proper engineering principles for the developments of AI or machine softwares is emerged. From the business perspective, despite a huge interest in adoption of AI, 85% of the AI projects ultimately fail to deliver their intended promised value, according to a recent international survey. It is reported that companies find challenges in both defining a suitable business case as well as developing an AI or ML solution that match this case. In traditional software projects, there's actually several methodological approaches to deal with these situations. One method called continuous experimentations is especially proposed and empirically validated for situations with high uncertainties, such as both business ideas and software solutions are not known in the beginning. The methods are based on the build, measure, learn, the famous concept of lean startups. And through several loops of build, measure, learns, minimum viable products can be developed and user feedbacks can be collected. In this way, hypotheses about our software, for example, our AI software, can be tested constantly with the user input. Starting from our current research interests, we think continuous experimentations can be a suitable approach for developing AI ML software in many scenarios. And for us to be able to do this, we need to look at the problems of developing AI software from both perspectives, technological driven and business driven. From the technical part, we need to understand on the training data, data management, model design, building, testing, and operations, and how they can be combined into the different business dimensions with specifying business needs, specifying the requirements, analysis and design, and buildings and testing minimum viable products. So in this slide, you find our proposal of the conceptual framework for continuous experimentation for AI software. The process is tailored for build, measure, learn process with a focus on AI software qualities as a non-functional requirement. So as showing in the figure, deriving from the customer needs, AI qualities as a non-functional requirement need to be specified and described. And after that, the quality attributes are analyzed and converted into designed and actionable elements. And the core artifact of the whole process is a list of minimum viable versions of the AI software that can be tested with actual users. This loop repeated at least 3 levels. We can see here the level 1 validation level 1 at the model idea level. Level 2 is to get the feedback with the training model, and the level 3 to get feedback with the operating version of the model. Be able to realize this conceptual framework and apply it in the real AI software projects, there are several research gaps that still need to be addressed. So the first one is right in the first phase, from customer needs to requirement specifications. The quality requirement specifications should connect to the business goals and reflect the organization objectives. They need to be specific and measurable to guide the downstream engineering activities such as analysis, designs, model building, and verifications. The second challenge is about the quality analysis. So once the quality attributes are properly specified, it is necessary to understand the relationship between these attributes and these attributes to other factors of the systems like business goals, infrastructures, cost, and project constraints. And you can see in the illustrating example here how a holistic view of such relationship can be. The third issues we identify related to the process of defining and implementing the minimum viable products as a key artifact of the whole process. It's most important to determine a set of minimum acceptance criteria that can be used to define an MVP. So we can accept or we can reject the MVP based on business and other organizational requirements. And software traceability. Traceability supports demonstrating that each requirement has been implemented satisfactorily. In AI software development, changes are made continuously during data processing, hyperparameters optimizations, and model experiments. A versioning system for AI needs to keep track of changes for both models and associated datasets. And last but not least is the need of a set of tools, supporting tools. As we can see here, through different levels, we need to go through the complete development pipeline of an AI software. Every step in the pipeline, such as data preparation, model building, model monitoring, are essential. And the tools support such as versioning control systems, issue tracking systems, automated testing frameworks are all needed in AI engineering as we need them in a typical software development project. To sum up, our proposal focuses on two major aspects, requirements and minimum viable products. The conceptual framework here for the research agenda addresses several key scientific challenges that are roadblocking for integrating business value into AI software. We offer several research questions as showing here. This is not a complete list of challenges, but there are important ones to bring engineering principles into AI software development.